Today we're breaking down one of the most important concepts in networking, the OSI model. And if you've ever been confused about where exactly a network breaks, this video is for you. The problem is that most people use the internet every single day, but don't really understand what's happening under the hood. And without that understanding, you can't properly troubleshoot issues. You can't really understand network security, and you definitely can't feel confident during technical interviews. And let's be honest, OSI questions show up in almost every interview that involves networking. If you want to grow in networking, cybersecurity, or system administration and aim for a solid IT salary, this model needs to be understood, not just vaguely remembered. So let's figure out what it actually is. In simple terms, the OSI model is the process of data transmission split into 7 logical layers, where each layer is responsible for a very specific function. This isn't an abstract theory or knowledge for the sake of knowledge. It's a practical way to understand who does what when data moves from one device to another. To make everything clear, let's go step by step, from the bottom to the top. The first layer is the physical layer. This is where everything starts. At this level, physical signals are transmitted, electrical impulses, light or radio waves, from sender to receiver. Here we deal with cables, connectors, contacts, voltage levels, and signal modulation. Simply put, this is the layer of wires and signals. One important thing to understand, at this stage, ones and zeros are not data yet. They're just physical phenomena. Technologies at this level include Ethernet, which defines how signals are encoded and transmitted over the medium. You'll also find Wi-Fi, Bluetooth, and infrared communication here. Yes, the same one people once used to share MP3 files. Devices at this level are extremely simple, hubs and repeaters. They don't think, analyze, or understand data. Their only job is to pass the signal along. If something doesn't work here, there's no point looking any higher. The second layer is the data link layer. We move one step up. Imagine a signal arriving from the physical layer, just raw voltages, waves, or frequencies. Now that signal needs to be turned into bits the computer can understand. That's the job of the data link layer. Here, data is packaged into frames, useful data plus service information like who sent it and who should receive it. The simplest analogy is a postal envelope. The letter inside is the data, and the address on the envelope is the service information. This is where MAC addresses appear. They uniquely identify devices inside a local network. A MAC address is the device's address at the data link layer. This is where switches and bridges operate. These devices are smarter. They can deliver frames to the correct destination instead of broadcasting everything. By the way, Ethernet actually works across 2 layers, the first and the second. You'll also encounter protocols like PPP, CDP, MPLS, and others here. The third layer is the network layer. This is where networking becomes global. Here we get routing and IP addresses. If data units were called frames at layer 2, at this layer they're called packets. When you enter a website address, a DNS request is sent, an IP address is returned, and that address is placed inside a packet. If we continue the envelope analogy, it's like having one envelope inside another, but now with addresses from a different layer, the network layer. This process is called encapsulation when data moves downward, and decapsulation when it moves upward. Each layer adds its own service information and knows exactly how to handle it. This is also where the ICMP protocol operates and where the ping utility is used to check whether a network path exists at all. The key device here is the router. Its job is to decide where to send the packet next across different networks. The fourth layer is the transport layer. The name speaks for itself. This layer is responsible for data transfer, order, and delivery reliability. The 2 main stars here are TCP and UDP. TCP is used when accuracy matters. If data is sensitive to loss, TCP takes full control. Files, documents, passwords, even a single incorrect bit can cause a failure. UDP works differently. It's faster and simpler. Small losses are acceptable. For example, in video streaming or online games, losing a couple of packets is unpleasant but not critical. In fact, while you're watching this video, some packets may already have been lost, and you didn't even notice. In practice, network engineers mostly work with the first 4 layers: physical, data link, network, and transport. But let's go higher. The 5th layer is the session layer. This layer manages connections and sessions. It establishes a connection, maintains it, and properly closes it. If a connection suddenly drops, this layer is responsible. A good example is an audio or video call. The session must be coordinated on both sides, including signal encoding parameters. The 6th layer is the presentation layer. This is where data transformation happens: encoding, compression, formats, JPEG, GIF, and others. When you send someone a photo, it doesn't arrive as an image. It arrives as a sequence of bits. This layer turns those bits into a format that can actually be opened and viewed. The 7th layer is the application layer. This is the top of the OSI model. It contains the network services users interact with directly: HTTP, HTTPS, FTP, SMTP. Open YouTube right now and check which protocol the site uses. Correct, HTTPS. That's the application layer. This layer allows applications to work with the network, transferring files, sending email, and making database requests. Now that you understand how the OSI model works, here's a question for you. Which layer is closest to you when sending data, and which one when receiving it? Write your answer in the comments. That's it. Nothing overly complicated. If this was useful, subscribe to the channel and write what topic you want me to break down in the next video and what exactly you'd like me to explain next.